Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. All right, so we have learned all the new stuff, so now we're going to go back and review stuff. So the first thing we're going to review is some limit stuff, mainly around horizontal and vertical asymptotes. So make sure your paper looks like this, horizontal and vertical asymptotes. That is the title for today. We're going to do some review, and then we're going to practice some AP questions and do a scrimmage. All right, so here we go. So here is a graph right here. Look, f of x equals x squared minus x minus 6 divided by x squared plus 9. So here's a graph right here. So all sorts of discontinuities going on. So how do you know without the graph what the discontinuities are? Where the horizontal asymptotes, and in that case it's this. See that y equals 1 going across like that. Y equals 1 is a horizontal asymptote. Or the vertical asymptotes, and that would be x equals negative 3. That's a vertical asymptote, aka an infinite discontinuity. Or there's a little hole at x equals 3. Okay? So how do we know all this stuff, particularly around horizontal and vertical asymptotes? So first thing right here, a vertical asymptote, write this down, pause the video. It's a point at which the limit as x approaches c of f of x is undefined. So you have an undefined limit. Also, horizontal asymptote. Remember, that's when x approaches infinity or negative infinity. That's when we have a horizontal asymptote at y equals something, as long as that's not infinity. So pause the video, write that down, and then we're going to do 1, 2, and 3. Here we go. Here's my notes right there, and let's go. So number 1. I know on the paper it says limit as x approaches infinity, but I'm going to do both here. So write this down. So let's say we're given a function that looks like this. Where are the horizontal asymptotes and where are the vertical asymptotes? So the graph looks something, I don't know what the graph looks like, something like that. All right, so first thing, horizontal asymptote. This is what you got to do. So you got to find the limit as x approaches infinity of 3x squared minus 6x and 4x minus 8. So that's going to be, well, this is going to be so small, it doesn't really matter. And so I just look at the biggest power on the numerator and the biggest power on the denominator, and it looks like this right here is bigger. This infinity squared is so much bigger than infinity, so that's going to be infinity. So there are no horizontal asymptotes for this function. How about some vertical asymptotes? How might you do that, you might ask? Well, all I need to do is set this equal to 0. So I want an undefined limit. So what I do is 4x minus 8 equals 0. When is my function undefined? Let's see. 4x equals 8, and so x equals 2 right there. So how do you know that it's an infinite discontinuity like this as opposed to just a hole? Well, I got to plug that in. So I got to find the limit as x approaches 2 of this thing right here. So I need to make sure I get undefined and not indeterminate. So that's going to be 3 times 2 squared minus 6 times 2 divided by 4 times 2 minus 8. So I know that that's 0 on the denominator because we already did that. But the numerator is going to be 4 times 3, which is 12. So that's 12 minus 6 times 2, which is also 12. This is 12 minus 12, and so this is just a hole. This is a hole. That is not a vertical asymptote. So then I would do L'Hopital's rule, or I'd factor, and I'd find my actual limit. But I know that there's a hole in the graph. So there's no vertical asymptote, and there's no horizontal asymptote for the first one. Cool. All right, next. Here you go. So f of x equals 10x to the 5th plus x to the 4th plus 31 divided by x to the 6th. Okay, so horizontal asymptotes, let's see. So the limit as x approaches infinity. So that's going to be 10 times infinity to the 5th, and then the rest is going to be negligible because it's not going to even compare to how big this number is, divided by infinity to the 6th. So that means that this number is so incredibly big and the numerator is so small. I know infinity to the 5th power, saying that's small is kind of weird, but you got to wrap your mind around it. Infinity to the 5th is so small compared to this that it's just like having 1 over something like this. So that's the same sort of idea. And so this is essentially 0. If you have one piece of pizza, or say if you have a pizza and you break it into infinity pieces, you only get one, that's basically getting nothing. So this is 0. So the horizontal asymptote is at y equals 0. Cool. Vertical asymptote now. So that's when x to the 6, the denominator. So I'm looking for undefined limits, and that's when it equals 0. Okay, so that's going to be, I'm going to plug into the limit as x approaches 0 of this thing, 10 times 0 to the 5th, plus 0 to the 4th, plus 31, equals 0 to the 6th. And this is 0 plus 0, so this is 31 over 0. That's an undefined limit, yeah. And so I have a vertical asymptote at x equals 0 right there. And so the graph is going to look something like this. So x equals 0 is this, and y equals 0 is that. And so the graph is going to look like this. Something like that. It could look like this, who knows, but it's not going to touch x equals 0, sorry, y equals 0 or x equals 0. Cool. All right, let's try another one. Let's do it. Here you go. So f of x equals. So pause the video, see if you can get this one. All right. Let's see what we got. So the horizontal asymptote is when the limit as x approaches infinity. So that's going to be, so the only thing I care about is this power. And then this is the biggest power in the denominator, so it's 2x to the third. And then infinity to the third divided by infinity to the third is 1. And so negative 2 divided by 2 is negative 1. And so y equals negative 1 is your horizontal asymptote. Cool. All right, vertical asymptote. 2x to the third plus 3x squared minus 5x. Okay. So I gotta set this equal to 0. So what am I going to do? Okay, so I'm going to factor out an x. 2x squared plus 3x minus 5 equals 0. Can I factor this? Let's see. 3 on the top. Ooh, a is bigger than 1, so I got to multiply 2 times negative 5 is negative 10. And I'm going to get, this is 5 and what, negative 2? There we go. So it's x times, well, I can just leave that at the end, actually. So I have x, sorry, 2x squared plus 5x minus 2x minus 5. No. What can I factor out of here? Yeah, an x. What can I factor out of here? Yeah, negative 1. So I have x minus 1, x, and then I have 2x minus 5 equals 0. Yeah, all that. And so x equals 0, 1, and set that equal to 0. What do you get? Plus 5, yeah, 5 over 2. 5 and then divide by 2, so you get 5 over 2, or 2.5. All these are potential vertical asymptotes. So how do you determine which one is which one is the correct one? Well, let's see. So you have to plug it in to make sure. So if you plug in 0, you're going to get an undefined limit. So the limit as x approaches 0, this is going to be 0, 0, so you just have 3, and there's 0 on the denominator. Bam. If you plug in 1, that's going to be negative 2 minus 2 plus 3, which is not 0, so that's also going to work. So limit as x approaches 1 is also going to work. And then if you have 2.5, let's get the calculator out. 2.5 squared. I'm using my calculator over here off to the side. Yeah, I'm cheating a little bit. Yeah. Sorry, 2.5 to the third power. 2.5 to the third power times negative 2 minus 2 times 2.5 plus 3 is also doesn't equal 0 on the denominator. So all three of these right here, 0, 1, and 5/2, when you plug them in, you don't get 0 on the denominator, so there's no holes. All those are going to be vertical asymptotes. So your vertical asymptotes are at x equals 0, 1, and 2.5. Bam. Cool. All right. So what are we going to do now? Let's do some practice one, shall we? All right. So let's go back to our notes. All right. So we're going to do this number 6, 7, and 8. See if you can do these 6, 7, and 8. Pause the video, then I'm going to do them, okay? 6, 7, 8. Ready, steady, go. Okay, here we go. Here's 6. So in order to find the limit as x approaches infinity, you cannot know what's going on yet because you don't know what the greatest power is because this isn't fully multiplied out. So you have 2x minus 1, 3 minus x, and so you have, this is going to be 6x, negative 3, and you have negative 2x squared, and then x. So the biggest power here is going to be this, negative 2x squared. I don't really need to know about that because the rest, when you plug in infinity, it's going to be negligible. Over, okay, so when I box this, anti-factoring, right, opposite of factoring, x squared, negative x, 3x, negative 3, this is the biggest power that's going to arise from there. And so this is going to be bam, and so your answer is going to be negative 2 over 1 or negative 2. Hopefully you got it right. All right. Identify all horizontal asymptotes. So I got to do the limit as x approaches infinity. So that's 5 plus 2 to the infinity over 1 minus 2 to the infinity. So obviously this is going to be incredibly big. This is going to be a exponential equation like this. Kind of like how the coronavirus is an exponentially growing virus. Bam. Just like that. You see a lot of graphs these days that look like this, exponential. So that's 2 to something power or 3 to something power. That's an exponential function. So it's this and this. And so this is going to be a positive and that's going to be a negative, and it's going to be the same value. So positive divided by negative is just going to be the same thing, and so it's going to be negative 1. Cool. So y equals negative 1. So the answer is A. Got it. Last but not least, when you plug in infinity, and it looks like x to the third and 4x to the third are the biggest powers. You plug in infinity, x to the third divided x to the third is going to be 1, and so your answer is going to be 1/4. Yeah. Hopefully you got all those right. All right, now what I want you to do is this. So let's push ourselves a little bit more. Let's knock these out right here. So I'm going to do another video coming up. It's going to be on this. Homework number 95, do it again. So here's where you have to find the limit as x approaches negative 2, identify the type of discontinuity, all this stuff. So I want you to do E, F, G, and H right now, and then watch the video. Don't watch the video first, try it on your own first. This is no calculator, so you should be able to do the rest, okay? Ready, set, go. Nice job.